Hi guys, you're welcome to my channel. Today I quickly want to go through a data structure problem on the two-sum problem. Let's see how the problem is. The two-sum. Yeah, consider that you're given an array of integers. You're to return the indices of the two numbers such that they add up to a specific target. You may assume that each input will have exactly one solution. So, and you cannot use the same element twice. For instance, look at this example. You have this array 2, 7, 11, 15, and you are given a target 9. So you're supposed to look through this array and check which two of the values in the array sum up to 9. For instance, in this case, 2 plus 7 give us 9. So your solution should return index 0 and index 1. So how can you solve this problem? There are various approaches you can use to solve this problem. First, I begin by analyzing the input. Yeah, assuming the array is empty, definitely you know there are no solution to return, so you return empty array. Another case would be if the array just have one empty element, that means you have no second element to add to that element, so no solution. Now assuming we have just two elements, so what you just do is that you add the two elements and compare the results with the target given, and if they are the same, then you return the indices of those elements. If not, you return an empty set. Now consider we have three elements. Now if the elements are sorted, one way is you may want to think of, if you pick the first element and you are like looking at where does the other pair fall into. So if you have elements like 2, 7, 9 in this way, so and you're given a target, and your target is say your target is 11, so you may want to pick the first element, which is 2, and subtract 2 from 11, okay, so which gives you 9, and you can start looking in this place for the 9. As one approach. Another approach could be that you can say, okay, add 2 and 7 together, okay, that gives you 9, and if that gives you 9 and compare 9 with your target, which means 9 is lesser than your target. So if you know that this array is sorted, then you can say that, okay, you can't pick 7, you need to pick a value that is after 7, that is bigger than 7, which you know that this array is in non-decreasing order. That's one way. But assuming now we don't have knowledge of the elements, we're not sure of whether the element is sorted or not, so this intuition might not work. But still then we have gotten an idea to subtract the first element from the target and continue to check the rest of the list. So but if we follow this approach, we discover that it's going to give us an answer, and you may want to try it, but we're going to end up having a quadratic time complexity, because we will need to check exhaustively on all the elements of the array and sum up to compare with the target, and that will mean for each element in the array we have to iterate the array for each element. So we have to go through from element 1 to the end for each element of the array, and that's going to give us a time complexity of n times n, which is n squared. You may want to try that. But the approach we're using here to make our time complexity to be linear, we're introducing a hash map. So we can introduce a hash map so that we will not have a time complexity of n square. But if we are introducing a hash map, we're going to be needing an extra space. So if you're using this approach here, we'll end up with time complexity of n square, and our space complexity will just be a constant space because we will not need to use any extra space. But if we go by the hash map, we'll have a time complexity of linear space, as you will soon see, but our space complexity will not be constant, so we're going to have a space complexity in the order of the number of elements in the array, which is n. It's just a trade-off between time complexity and space complexity, so the choice is left to us. Now, so a better solution for time complexity is to use hash map. And how can we do that? Insert each element of the array into an hash map and subtract the first element from the target and get the value of the remainder in constant time, like I showed in this slide. So first of all, we have this array. So we insert each element. 2 goes into our hash map, 7 into our hash map, 9 into our hash map. And when we're inserting into our hash map, we also take note of the indices, the array index of each of these elements. Like the array index of 2 is 0, the array index of 7 is 1, the array index of 9 is 2. So we put both the value and the array index into our hash map, and we subtract the first element, this element, which is 2, from our target to get 9. Then we now feed in the remainder, which is 9, into our hash map to see whether that remainder exists in our hash map. It's just a simple concept of using hash map. So let's see that in Java implementation. So okay, so this is our method. This is our toSum method. The method takes the array, as we said. This is the array, and it takes our target. So the next thing is for us to build a hash map. Now we have some utilities variables here to be able to help us check when the solution is found. And when we don't have a solution, we can return this array, this empty array, that there are no solution. So let's see how we build our hash map. So how do we build our hash map? We have map, we have integer, map, new hash map. So this is create an hash map object with the object name is this small letter MAP. Now, what does this hash map means? It means that we have a key value pair. Both the key and the value, they are integers. So you can check more on other tutorials about how a hash map works, but this is the implementation of declaring a hash map object. You have a map, which means you are going to import a map object from java.util to use a map interface, and you're going to import a hash map class also from java.util hash map to use the hash map implementation. So now this code are following in sequence. After this, you follow to this. So we iterate through our array, which is the nums.length. So we iterate through our array, and the first time we iterate, we get the first element, which is I, and the map that we have declared, if you look behind the map that we have, the hash map object, we put the value of the array and the index. If you check in this, the first part of this tuple is the key, and this is the value. So what we're trying to do here, we are making the key of our hash map to actually be the value of our array, and there's a reason for doing that, which you will see next. And we are making the value of our hash map to be the key the index of our array. So we create our key value pairs corresponding to the value and the index. And now we move on. We declare a counter I equals to 0 while we are yet to reach a solution stopper. Then we iterate again through the array nums. We iterate through the arrays. Then we get the first element of the array, which is I equals to 0. We subtract the first element from our target to get a remainder. Then we take that remainder and check in our map. So we check in our map if we are able to get if the remainder is found in our map. You know now that the map contains all the values that are in the array nums. So, and because we have made the key to be the value, so we can just send it that do we have this remainder in our map as a key. And we also check, because we don't want to do the same summation. We don't want it to pick the same numbers. For instance, if we have if I pick 4 here, if my target is 4, then the only thing that can give me 4 will be 2 plus 2, which is 4. We don't want that. We don't want to pick the same index twice. We want to make sure we have different indices. So for us to be able to achieve that, we check to make sure that the map dot get remainder, the key, the value of our remainder is actually not the same as our current counter, which is I. So we make sure that that is not it's not taking the same counter, the same index as our is not taking the same index, so that it will not be adding itself. It's not adding to itself. So we do this, and if this condition is satisfied, we can return a new array. So this is how to create a new array of integer in Java. So a new int, then we take that index, that current index, that current value of I, which whatever it is. Then we get this map.get remainder. We get the index from our hash map, which we have compared that is not the same thing. So this so that this I will not be the same as the result of this map.get remainder. So that's just the simple thing there. If that is the case, we return the solution. If that is not the case, if any of this is not satisfied, we just increment our I to go and pick the next value in the nums, to go and pick the next index, and it goes on like that until it satisfies this if condition. And if this if condition is not satisfied, when any of these when this becomes false, that is our I is now equal to the nums let, then we get out of the while loop, and we return no solution. But if at any time when we get into this if loop and we are able to get a solution, we get to return a solution, then we can get out of this while loop, because our stopper becomes true and this one becomes false, and so the while loop definitely we exit. So that's just it. You can find the code on my GitHub, and the time and space complexity is big O of n, as I said. Thanks for listening. Your comment highly appreciated. Thanks for listening. I'll just do a quick demonstration of that. In this. Can see a quick demonstration of the code. So here is a full implementation of the code. So this is the full implementation of the code, and I've put in here as 2, 7, 11, 15, and I have 17 here. So I expect the result to be 0, 1, 2, 3. So 0 and 3. So if you run this, if you run this on my Java, you can just do a Java, and then you do a Java, then you can see it's printing out 0 and 3. And if I decide to change it and I want it to give me 11 plus 17 plus 15, that is 26. So if I put in 26 here, 26 here, so I expect it to give me that is 0, 1, 2, and 3 as my index. So let's see whether that works. So you can compile it again, and then you run it. So as you can see, we have 2 and 3. Thanks for listening, and see you in another video. Thanks.